Section 1.1, we're going to look at analyzing categorical data. So first, we should probably talk about what that means. Okay, so when we look at data, we have the individuals, which are the subjects, the people, places, or things that are that we're collecting data from, and then we collect different variables, okay, different information about them: age, height, gender, ethnicity, address. All of those things would be variables. Okay, we split variables into two categories. They're either categorical or quantitative. All right, so quantitative is numbers. All right, anything that is a count or a measure, and categorical is anything that is not. Now, the one thing I want to caution you about when we talk about quantitative variables, being a number doesn't automatically make something quantitative if it's not an actual count or a measurement. Okay, so if it could be replaced with a letter just as easily, then it's not quantitative. A really good example of this is your social security number. Okay, it's an identifier, it's a number to identify you, but it doesn't tell us anything about you. So if I took the average of the class's social security number, that wouldn't tell me anything about the class. So even though it's a number, it's still a categorical variable because it's not a measurement. Okay, so here's an example. We have some data. So the people would be our individuals, and then the variables that we collected were what province in Canada they live in, their gender, the number of languages they speak, what hand they are, their height, their wrist circumference, and how they prefer to communicate. Okay, so like preferred communication, province, gender, those things would be categorical variables. And then number of languages spoken, height, and wrist circumference, those would be quantitative variables. Okay, so we can do something called a frequency table, and that's just where we put a count of however many people chose the same answer. So this one, they did what's your preferred method of communication, and 2 people chose cell phone, 1 Facebook, 3 in person, 4 text. Okay, the other thing we can do is called a relative frequency table, and that's just where we turn everything into a percent. Okay, so you'll see the decimal, sometimes they read as a decimal, sometimes as a percent. It just matters if the question asks you for a proportion or a percent, so just pay attention to that. Okay, ways that we can display this data instead of just a table of numbers is we can do a bar graph. Okay, so nothing special. Take it all the way back to elementary school. Literally just draw bars, make sure that they are spaced out, and make sure that everything is well labeled. All right. And this would be what I would call a relative frequency bar graph, because the percent is what is on the side. So instead of the number of people that chose each thing, they did the percent of people that chose each thing. We could also do pie charts. Okay. Again, percents. All right. This time it's in a circle. Biggest thing with a pie chart is everything has to add up to 100%. So if you don't have information for everybody, you would need like an other slice of the pie that gets you up to that 100%. Okay. We talked about this like the first day, but even though bar graphs or pie charts might look a little boring, we should not be using what they call pictographs, where we use like 3D pictures or effects to model something, because it messes with the scale of things and portrays something that's not necessarily true. So before, we were looking at one variable at a time, so just what was someone's preferred method of communication. We also sometimes need to look at 2 variables at a time. So in this case, we wanted to look at whether or not someone was a member of environmental club and whether or not they used snowmobiles. Okay, so when we have 2 variables at one time that we want to analyze or look at, we would do what's called a two-way table. All right, so we make this little table. And in here, we would count how many people are not a member of environmental club and never use a snowmobile. And that's what goes there, right? Not an environmental club, rent a snowmobile. Not an environmental club, own a snowmobile. So we just have those numbers, and it's usually pretty helpful to go ahead and put totals. So we put the total across the row. So 445 plus 212 is 657. And then we also put the total down the column. So we add these 3 numbers together. And then whenever you make a two-way table, just check yourself. These 2 totals here should add up to the same thing as these three totals here. So if both of those numbers don't add up to the same number, in this case 1526, then you have an error somewhere in your counts. All right, so with two-way tables, we can find a couple different kinds of frequencies or percents. The first one is called a marginal relative frequency. I'm not really too concerned about you knowing the name. It's more about being able to answer the question. So that's when we just look at one variable, so out of that total row. So if I wanted to know how many people are not in environmental club, I can just look down at that total, and then it's always out of the grand total. So 80% of the people in this data were not members of the environmental club. Okay, we can also do what's called a joint relative frequency, and that's when we look at two specific variables at the same time. So if I wanted to know what percent are in environmental club and own snowmobile, so I'm looking at the intersection of those two things. Yes, for environmental club, and owner for snowmobile, there are 16 people in that little group, so 16 out of 1526. All right, then the last thing that we can look at is called a conditional relative frequency. All right, and that's when we are just looking at within a certain group. So I'll give you an example. Okay, what percent of environmental club owners are snowmobile owners? So this time I don't care about anybody in that no column. I'm only looking at people who said yes, they're in environmental club. Out of those people, there's 16 snowmobile owners, so it's 16 out of 305 because, again, I'm only looking at the environmental club owners. Something else that they love to ask is ask you to list the distribution. Okay, the distribution. Think about what the word distribution means. It means how are our people grouped within something. So we'll look at an example. What is the distribution of snowmobile use among environmental club members? Okay, so out of the environmental club members, how are they grouped as far as their snowmobile use? So anytime they ask you for a distribution, they're asking you for a list of percents. Okay, so what percent of users never use a snowmobile? Or what percent of club members never use a snowmobile? 212 out of 305. What percent rent? What percent own? Okay, so the distribution means to list out all of the different groups and then what percent are in that group. Okay, so same thing. Here's another example. We can find the distribution of snowmobile use among people who are not an environmental club. All right, so same thing. Now we're looking at the no column. What percent never used, rented, and owned? Okay, some things for you to keep in mind answering free response questions, especially for the AP exam. Percents, okay, so those relative frequencies are going to be safer to use than counts because if our groups are different sizes, then those numbers don't match up. So, you know, if I have a group of 15 and I say 5 out of 15, and you have a group of 1,500 and say 10 out of 1,500, like those are very different things. Okay, so we'll stick to relative frequencies. It keeps you safe if your groups are different sizes. But when you do that, we got to make sure that we use the correct words. So we can't say things like more members. We have to say a greater percentage. Okay, so stick to those percentages and then use the word percentage in your answer, and that'll keep you pretty safe. Okay, last thing that we can look at to compare, because those two-way tables, again, are a lot of numbers, is that we can split things into two different graphs. We can do either a side-by-side bar graph, or we can do what's called a segmented bar graph. Okay, so in a side-by-side bar graph, we did out of the people that are not in environmental club, the percents, and then out of the people that are in environmental club, the percents. Okay, so that's one way to look at the data. The segmented bar graph is going to stack these things on top of each other. Okay, so not in environmental club, percent, 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 percent. Okay, so both give us like a really clear picture of how the two groups differ, because I can see like how big that blue bar is over here and how small the green one is, and then same thing over here, I can see them stacked next to each other. And one thing that those segmented bar graphs do is they help us see if there's an association between two variables. If those graphs look very different, then there could be an association there. So if we look at this, the never use category is very different depending on whether or not people were in environmental club. The own category is very different between the two clubs. Okay, so we can say that there's an association there. Okay, people in the environmental club were way less likely to use a snowmobile. All right, if there was no association, then the graph might look something like this, where they are very similar and all of the different colors are roughly the same size. All right. Now, just like we talked about last time with our experiments, okay, association does not mean causation. Okay, just because we see this association on the graph doesn't mean that we can say being in the environmental club causes people to not use snowmobiles. That requires much more research, but we can see an association just from looking at that graph. And that's it, guys.